Derivation of formula of gravitational potential energy. Gravitational potential energy is energy of an object due to its position in Earth's gravitational field. The scenario here is that we are raising a ball over a height delta y, and to raise the ball we are applying an external force F external. This could be force by hand. We are raising the ball at a constant speed. The speed of the ball as it goes from the initial position to the final position does not change. So there is no change in kinetic energy of the ball, only height is changing, and thus only gravitational potential energy is changing. The free body diagram is shown here. The F external is the force by the hand, which is equal in magnitude and opposite in direction to the weight of the ball. And during this process the ball gains the height delta y. So ball is raised at constant speed, which means that the net force is 0, and ball is gaining gravitational potential energy. Why can we write this equation? W equals change in energy because of work energy theorem. Now change in energy is equal to change in gravitational potential energy. Why can we say that? Because the only change in energy here is gravitational potential, and there is no change in kinetic energy here. And we expand delta GPE as final gravitational potential energy minus the initial gravitational potential energy. Let us label it as equation 1. We will come back to it later on. Work done during the process of raising the ball can also be written as W equals Fd cosine of theta. And why can we write this equation? Because it is definition of work done. In the situation here, we were applying an external force which was upward, and the displacement, corresponding displacement, was also upward. Angle between these two vectors is 0 degrees, so cosine theta here, theta would be 0 and cosine of 0 is 1. And I have replaced d here with delta y as shown in the diagram, and the only force whose corresponding work we are looking at is the external force. The external force is equal to the weight, because in the free body diagram the weight was balancing out the external force, and ball was raised at constant speed, so the net force was 0. Why can we write this? Because the formula for Fg is mg. And let us expand delta y as yf minus yi. I am distributing mgy here, mgyf minus mgyi. Let us label this equation 2. Now let us compare equation 1 and equation 2. Equation 1 says that the work is equal to final gravitational potential energy minus the initial gravitational potential energy. And the second equation says that work done is equal to mgyf minus mgyi. If we compare these two, we can conclude that the general formula of gravitational potential energy is mgy. We could choose that yi, the initial position of the ball, was 0, which means that initial gravitational potential energy was also 0. Let us look at the units of gravitational potential energy. Because it is energy, it should have units of joules. So mass has units of kilogram, g has units of meter per second square, and y has units of meters. So we write all this. Now kilograms meter per second square is equal to newtons. So newtons times meters gives us joules.